Assalamualaikum and good morning everyone. Today we are going to discuss about inhibitors. Okay, and there are two types of inhibitors: competitive inhibitor and non-competitive inhibitor. Inhibitors, okay, are chemical substances that slow down or stop enzyme reactions. If these inhibitors, okay, are attached to an enzyme by covalent bonds, inhibition is usually irreversible. But if these inhibitors bind to the enzyme by weak interactions, the inhibition is usually reversible. And many enzymes inhibitors apparently can bind to the enzyme by weak interactions. Now let's discuss the first one, the competitive inhibitors. Competitive inhibitors, they are chemical substance or molecule that compete with the substrate for the active site of the enzyme, as you can see in this diagram. The enzyme has higher affinity for the competitive inhibitor molecule than the substrate molecule. So obviously that the competitive inhibitor will gain access or bind to the active site of the enzyme, because the enzyme has higher affinity for the competitive inhibitor rather than the substrate. And when this competitive inhibitor molecule already bind to the enzyme active site, okay, this condition will block the substrate from entering or bind with the enzyme active site. Competitive inhibitors has similar shape with the substrate molecules. Now, these competitive inhibitors, okay, reduce the productivity of enzymes and can be overcome by increasing the substrate concentration. Why does these competitive inhibitors reduce the productivity of the enzyme? Why? Because by right, okay, the substrate should bind with the enzyme active site. When the substrate bind with the enzyme active sites, okay, it will progress to the formation of the enzyme substrate complex, which in turn ultimately will progress to the formation of enzyme with products. But if competitive inhibitor bind with the active site of the enzyme, we don't get the enzyme substrate complex. Okay, so without the enzyme substrate complex, there is no formation of products. So without formation of products, the productivity of the enzymes are reduced. Okay, fortunately, competitive inhibition can be overcome by increasing the substrate concentration. Okay, because most substrate molecules, okay, then the inhibitor molecules are available to bind with the enzyme active site. So this eventually increase the productivity of the enzymes, which is the formation of the product. Right? Now, competitive inhibitors will cause the value of the Km to increases. You can see from here. Higher Km means the enzyme has weaker affinity towards the substrate. Okay. Now here I mentioned competitive inhibitors cause the Km to increases. Higher value of Km means enzyme has lower affinity for the substrate. Betul kan? Because it's very obvious the competitive inhibitor molecule competes the active sites of the enzyme with the substrate, and the enzyme has higher affinity for the competitive inhibitor. And here you can see, okay, there are three graphs here. Okay, without inhibitor, right? Without inhibitor, the enzyme has high affinity for the substrates. Okay, because the value of the Km is low. Okay, this is the graph without inhibitor with the Km here. It's relatively very low. Okay, we can get the Km at half Vmax, right? So this is the maximum velocity, this is the half Vmax. So when inhibitor is being added, okay, this is the graph that we obtain, and from this graph this is the value of the Km, slightly higher. So, meaning to say the enzyme has lesser or less affinity towards the substrate because of the presence of the competitive inhibitor. Now, what happens if we further increase the concentration of the inhibitor? Look at the value of the Km. It further increases. Okay, further increases. Okay, this is based on the mechanism maintained plots. Now, if we observe the Lineweaver Burke plot, okay, without inhibitor, look at the value of the Km. Without inhibitor, it's very small. It's further negative. But when inhibitor is being added, okay, this is the graph that we obtain. Look at this line here. Okay, the value of the Km increases. Okay, without inhibitor is further negative. With inhibitor is slightly negative. With more inhibitor, what happens? The value of the Km further increases. Okay, at half Vmax. Now, when it comes to the Vmax, all right, the maximum velocity remains the same. Okay, either with or without the competitive inhibitor. Value of the Vmax or maximum velocity remains the same. But, okay, the downside of it is the enzyme takes longer time to bind with the substrate. Okay, due to the availability of the enzyme active sites. T of the enzyme active sites, right? Now, example of competitive inhibitor molecule is malonate. This malonate competes with the substrate succinate for the active site of succinate dehydrogenase. Okay, succinate. Okay, with succinate dehydrogenase, you will learn in detail later in the respiration chapter 5. Right now we are in chapter 4. Then upcoming chapter 5. All right, no worries. So for this part now, in this competitive inhibitor, what you need to know is that malonate is one example of competitive inhibitor that competes with succinates. Okay, for the enzyme succinate dehydrogenase active sites. All right, the other inhibitors is non-competitive inhibition. What do you think about non-competitive inhibition? You need to say there must be a molecule that does not compete with the substrate for the active site of the enzyme. Okay, so what does this non-competitive inhibitor molecule does? So this non-competitive inhibitor molecule is a molecule that binds to the allosteric site of the enzyme. You can see this diagram here, right? This is an enzyme with this allosteric site, and apparently the allosteric site is being bind with the non-competitive inhibitor. Now, when this non-competitive inhibitor bind with the allosteric site of the enzyme, what happens? All right, this non-competitive inhibitor will cause the active site of the enzyme to be changed. Okay, to change its shape. So meaning to say the enzyme denatures and become less effective. You can see in this diagram how the substrate cannot bind with the enzyme active site because the active site of this enzyme is already changed. Okay, the shape of this active site is already changed due to the binding of this non-competitive inhibitor with the allosteric site of the enzyme. So non-competitive inhibition is irreversible. Okay, and inhibition cannot be overcome by increasing the substrate concentration. Okay, it is irreversible, and you cannot overcome inhibition of this non-competitive inhibition by increasing the substrate concentration, unlike the competitive inhibition, which can be overcome by increasing the substrate concentration. Luckily, this non-competitive inhibition is reversible if the inhibitor leaves the allosteric sites or the disulfide bridge in the allosteric sites. Okay. Let's skip. Now, example of non-competitive inhibitor molecule is heavy metal like mercury and arsenic that will combine or bind permanently with the sulfhydryl groups at the allosteric site of enzyme. It causes the enzyme to denature. Why the enzyme denature? Because the binding of the non-competitive inhibitor molecule to the allosteric sites of the enzyme will cause the change of shape of the active site of the enzyme. So the enzyme denature and become less effective. Okay, another example is cyanides. Cyanides, okay, stop cellular respiration by inhibiting the allosteric site of cytochrome C oxidase in mitochondria. Okay, you will learn more detail about this cyanides, okay, that bind with the allosteric site of this cytochrome C oxidase in mitochondria later in chapter 5. So, non-competitive inhibitor will cause, okay, when it comes to this mechanism maintained plot and the line Wilber-Burki plot, okay, non-competitive inhibitor will cause the Km to remains the same. Look at this mechanism maintained plot. Okay, without inhibitor and with inhibitor at half Vmax, let's say this is the half Vmax. Okay, at half Vmax, so the Km remains the same. Okay, at half Vmax the Km remains the same, or here as well. Okay, so the half Vmax remains the same. But the Vmax decreases. Okay, maximum rate of reaction decreases because the number formation of enzyme substrate complex decreases. Betul kan? Because the enzyme cannot bind with the substrate. When the enzyme cannot bind with the substrate, obviously the formation of the product will decrease, because the number of the formation of the enzyme substrate complex also decreases. So Vmax decreases. So without inhibitor, you can see the Vmax is quite high, but with the non-competitive inhibitor, the Vmax decreases. Okay, and here in the line Wilber-Burki plot, you can see, right, without inhibitor, this is the Vmax, right, but with the presence of the inhibitor, this is the Vmax, okay, which decreases. Turnover number decreases. Okay, you see the number of enzymes in the system remains the same, but the number of active functioning enzymes decreases. Okay, this should be enzyme turnover number decreases, both the parts. Okay, so you can, from here you should be able to compare and contrast between competitive inhibitor and non-competitive inhibitor. Okay, so see you in the next video. Goodbye.